This paper was presented at the JCT Traffic Signals Symposium 2023 in Nottingham, thanks to the support of AGD Systems, INRIX, Message Maker Displays, PTV Group, Simplify Systems, Smart Micro UK and TRL Software.
Right, so signalling the end of temporary traffic management. So the presentation just explored temporary signals and traffic management. Quick insight into that, the current standards and guidelines in place, and then I will mainly concentrate on the case study of where we use temporary traffic signals in Bracknell. And then we'll look at summary and conclusions. So just a brief timeline, a bit of a quick overlook at what is there. So as you can see, I won't read through all that, but the first traffic cone made of concrete, supposedly, and now there's estimated to be 140 million cones in the world, so most of them on the M25. 1960s, the first portable traffic signal or light. These are not to be confused with temporary traffic signals, which are permanent traffic signals placed in barrels or concrete foundations, temporary foundations. We look at some of the acts as well that came in: 1980 Highways Act, 2008 Traffic Management Act. So that shows you a timeline. Where we are today, majority of the times we're using adaptive temporary traffic signals. There's many companies here outside in the exhibition providing those facilities, and local highway authorities and network people obviously know about these too. So that's the timeline. Now, I'm not pretending to be or would confess to be an expert on traffic management. This is just an overview of this. So it looks at the solutions available. Now, solutions should be considered and will depend on several variants. So size of the scheme, length of works, network type, users, etc. So you can see there's different solutions for different scenarios. So mobile traffic management, crash cushions to be used on the National Highways network and other fast roads. Diversions, lane foreclosures. Then we're looking at temporary VMS signs to assist in any traffic management put out on the street. Now solar powered as well as generator. Stop-go boards. Interesting, I found that there are actually robot versions of these now, so that's a innovation. And then we look at portable traffic signals, so battery or solar. And then we look at whether they're fully or locally connected, also known as PTS, and then TTS, which are temporary traffic signals, so fully or locally connected. Now, the future, it depends on what we're going to be using to travel around in the future, whether flying vehicles take off, so yeah, that's just a quick overview of traffic management now and the future. Industry standards and guidelines. Obviously, different industry guidelines and standards and acts that apply to the things that we're looking at there. So traffic management, Chapter 8, TSRGD, DMRB, as people have discussed already today. Portable and temporary traffic signals. We look at Topaz. There's a large number of TALs out there as well, and British standards, which obviously ourselves at Yunex and other suppliers need to abide to. And then there's generic acts and standards that people need to follow, and they're all detailed there. It's just a thought for the day. So, the case study. Feel a little bit of a con artist because signalling the end of temporary traffic management is a little bit woolly in the title. There was no paper provided prior to this, but we felt we couldn't do another plus presentation because people may yawn. So we'll look at the case study. This goes into a bit of the technical side of it, how consultancy services were involved through Yunex. So we've got an existing set of traffic signals in Birch Hill, roundabout in Bracknell, which is under the control of Bracknell Forest Council. So we'd like to thank them for allowing us to underdo this work and take this presentation. So it's located on the 232 between the M3 and the M4. It's a hamburger roundabout. So you've got 2 lanes heading north and 3 lanes heading south with then 2 side roads. The one to the west is into a main industrial estate and retail park, as well as residential properties. Now, how do I get my notes down? Sorry. Right, so the road is a 50-mile-an-hour road, speed limit. Existing control on site is a Siemens LV, 33 poles in total. Currently running, was running CLF stroke mover and was UTC as well, UTC stroke scoop. No pedestrian facilities, tall poles, mixture of tall poles and 4-metre standard poles. The existing enforcement camera on the southbound approach as well. Bracknell Forest approached us because they wanted to modernise the signals. They did their own detailed design and then came and approached Yunex in 2020 for a price for the modernisation. So they approached us in April 2020. Keith Manston was still around. And initially, we priced for a ELV solution and also provided a price for a permanent plus solution. Yunex Traffic would work alongside Ringway, who are the principal contractor. They would be providing the traffic management, PTS stroke TTS, and the programme for delivery of the scheme. Yunex Traffic would be subcontracted to them and providing supply and installation, validation of the signals. So that was the initial solution. Through discussions, with Bracknell and Ringway, it was an intermediate solution where we looked at using plus as the temporary traffic signals for the scheme, rather than bringing in hired, portable or temporary traffic signals. Initially, the programme looked at 6 different traffic management layouts, which therefore meant that we would have to provide 6 different plus layouts on street. Not impossible, but a lot of work. So we priced, following discussions internally with engineering department, tendering department, consultancy services department, we priced the temporary solution, including additional work for consultancy services, field services, and some of the associated equipment that would need to be allowed for the temporary scheme. Further meetings with Bracknell and Ringway pulled the scheme down from 6 potential traffic management layouts to 1 traffic management layout, where Ringway felt that they could do a lot of the civil works within that 1 layout and with minor amendments. So we went from providing 6 potential layouts with regards to plus to a 1 temporary layout, allowing conversion from a temporary layout to a final permanent layout. We allowed for FATs, SATs, and we also proposed the use of temporary pole block foundations. So the first process in this was to provide a permanent plus solution. So we take the local authority's detailed design and we carry out a conversion using the plus tool, which is available from technical downloads page, used alongside AutoCAD and key signals. We provide that conversion by overlaying cables, signal heads, etc., etc. And this all depends on whether on the duct layout that's allowed on street or it's going to be proposed to be put in. With regards to this, the final permanent solution used 3 CICs, as you can see on the screen. You use 7 rings, and these were determined by using where the poles were located and the duct network. All loops, so in this case, were wired back to the controller using standard 1 or 2 pair feeder cable. We proposed 2.5mm plus cable on this site due to the load on the rings. We could have used 1.5mm if we had issues with duct capacity or getting potentially using slot cutting, etc. But that would have increased the voltage drop across the site and therefore limited the capacity within the controller. This is the power table for plus. So you can see there that we're averaging around about 60% power load. Each CIC had 2 power supply units and a redundancy module. The redundancy module provides load balancing and across the PSUs, and therefore if one does fail, then the signals do not go out. So we had a final solution which we then turned into a temporary solution. So it mimicked the permanent solution. We provided a detailed design for that, which included the transfer of temporary solution over to the final solution. So the table shows you what we showed would be transferred from the temporary signal pole over to the permanent final solution. The temporary solution used CLF with demand-dependent phases, just because Bracknell's UTC plans and mover dataset was out of date, and therefore we validated using CLF on street. And that allowed us just to use MVDs during the temporary solution. So here you can see how we installed the poles into the temporary foundation blocks. Existing ducts were used for the plus cable. The installation was done on the ground to reduce working at height. So 3 stages of installation for temporary signals. Temporary signal was installed and cabled within the temporary foundation blocks and bagged over. Scheme traffic management was then installed for the first phase of the scheme, and then we switched over from the existing LV circuit to the temporary plus control system. The program works. So you can see install plus controller took 4 days. That includes civils and ground clearance. Then we looked at the plus installation, the temporary status. Now that took 17 days, included a day for the blocks to be put in place and a day for the SAT of the temporary solution. And civil installation had a total of 39 days. And then we had the permanent plus installation of 16 days. Now, the bonus of this was that the program showed with an ELV solution that we would follow the civils in after they had completed. With regards to using a temporary plus solution, we already had the plus equipment on street, and as the civils finished a certain area, we were able to follow in and transfer the poles from their temporary location over to their final pole socket location. So it saved time in the program and reduced the impact on the travelling public. So, summary and conclusions. Got an orange light, so there we go. So it's quite an honest issues and lessons learned. We did have some poles damaged during the initial installation process. Now, we looked at the process we amended that process to reduce those damaged poles and replaced all poles at cost to Yunex. Design and installation process was inefficient because this was pretty much the first time we'd done this. So we've now made that more streamlined. We did have some fails and all-outs during the switchover from the temporary to the permanent solution. A lot of firmware changes and the engineering work has been done on that to remove that. Temporary foundation blocks were quite large, so in some locations they were quite difficult to place away from what was going to be the existing, the permanent pole sockets. Wiring of poles, field services were learning as we were going. We had a road traffic accident. And then the plus tool, we had to version there's a facility within the tool to version your designs. So we had to version the permanent design to then be able to mimic the temporary design. And then when we first did that, wasn't clear on how to do that. So we've learned a lot over this case study. Scheme win and benefits. We eliminated the need for PTS and TTS, so no hiring in of other bits and pieces. The permanent equipment was there on street, being used temporarily, and therefore reduced travel and CO2 for bringing that and taking those PTS, TTS from site. Reduction in programme. We had the adaptive facilities on street to be able to control, which you can do. Full UTC monitoring throughout. And yeah, we had other savings including less copper cable and embedded CO2. So summary and conclusions there, just on traffic management really. Adaptive TTS products pretty much used as standard, I would say, going forward. All depend on size of scheme, length of works, network type. But traffic management should be safe, inclusive, practical and legible. For the case study, it's ensured the product robustness going forward. Plus advantage, you can talk to guys on our stand about that for going forward. It provides another product in a suite of products out there to be able to be used on street. And personally, I'm just proud to be involved in this scheme. It's 2 or 3 years of hard work from myself, engineering, tendering, so it's very good. So, red lights on. Thank you.
Thank you very much. Thank you very much, Andrew, for that detailed case study, which I'm sure lots of people in the audience found really relevant and interesting. Do we have some questions for Andrew? Yes. Always someone right at the top.
I'm just going to ask the obvious question. It's the end of temporary portables, but if you're actually swapping out your new equipment from a temporary foundation into your new permanent foundation, those signals are obviously going to be off at that point, so you're still going to need to have some sort of traffic management in place at that point. So what were you using at that changeover state?
So, as the time flew by on that presentation and stuff, I didn't make that quite clear. Obviously, with Plus, we were using the Plus system in temporary foundation blocks. So, as civils finished their pole socket on pole 1, we would be able to take the pole, disconnect that pole and because of ++'s capability, it wouldn't switch the site out. So you would be able to disconnect a pole, remove it, put it in its permanent foundation, pole socket, wire it back up, and then the site would remain on. So that's the benefit. That's one of the main benefits of doing it, because you are reducing the program. Plus, also with ++'s capability of using the rings, there was the contingency and the facility that the site didn't switch off.
There must be a safety issue with working without a signal. You've got a risk assessment process to cover that?
You would, yeah, we would need to. I mean, you would need to program. That's why there was the if it went back, you'd look at the temporary switch over table from where the signal poles were and the signal heads and the equipment was before to then where it was now. So if you, for example, a lot of the signals and approaches on that had multiple signal heads for that approach. So you weren't talking about a primary and a secondary only. You were talking about two primaries and maybe a secondary head. So the risk was limited to that. I take your point, because going forward you'd probably have to undertake that risk based on that approach. But you would try and limit downtime for that signal and that approach. But the system would remain on. So even for that approach, if you had one signal on, which could be, you could have had that for months because you've got a fault anyway. But for the other approaches, it all remains on. So the risk is limited because you don't have to switch the whole site off. You know, you're not switching over from a portable set of traffic signals to a permanent. There's no downtime. You should be able to just disconnect, remain, the remainder stays on, and then you connect back up. So your downtime is limited.
Okay. Am I allowed to take one more?
No, it's Chris Kennedy.
Yeah.
No.
Oh, no. Let Chris speak.
It's a difficult question, Chris. I know where you live.
I moved. Thank you. It really was just asking about the transition between, but presumably you had different requirements for the temporary setup compared to the final arrangement. Did you have much wastage or reworking from the temporary setup to the permanent one?
Wastage as in what, equipment or?
Equipment, or potentially what I was really wondering about was cable lengths, whether you had to extend any. Presumably you're putting stop lines in different places, putting signals in different places. Certainly back in the days of poles in barrels, one of the things we'd commonly have to do would be extending cables.
Yeah.
But that was with the old stuff. Well, you're putting brand new stuff in.
Yeah.
So did you find going from the temporary setup to the permanent that you had to recable again, or? So
there's no recabling. The cable that was installed for the temporary layout was used for the permanent layout. So what we did was we allowed a contingency or an additional element for the temporary layout. So then when the poles went into their permanent sockets, there was still that cable there, enough cable there for you to install into the permanent setup.
Thank you.
And the permanent setup almost mimicked the temporary setup anyway. It's just a matter of relocating that signal equipment.
Okay, that's great. We'll wrap it up there. Thank you very much, Andrew.
Thank you.
And yeah.